Hello, and welcome to Cloud Native Data, Everything's Stateful. Today's webinar is sponsored by Veeam and produced by Actual Tech Media. My name is Scott Becker. I'm from Actual Tech, and I'm excited to be your moderator for this special event. Now, before we get to today's great content, we have 4 housekeeping items that will help you get the most out of this session. First off, we want this to be an informative event for you, so we encourage any questions in the questions box in your webinar control panel. Not only will we have team members responding to questions during the live event, but we'll also have a dedicated Q&A session at the end of the presentation where we'll discuss in greater detail some of the top questions that you have. That Q&A panel is also the place to let us know about any technical issues that you might be experiencing. A browser refresh is going to fix most audio, video, or slide advancement issues, but if that doesn't work, just let us know in the Q&A and we'll provide further technical assistance. Now, second, in the handout section of your webinar control panel, you'll find that we are offering a lot of resources today. I'd especially like to call your attention to some things from Veeam. So there's 5 best practices for Kubernetes native data protection. There's an application mobility interactive data, demo. There's free trial of Veeam Kasten. There's a Kasten product overview. And there's a Kubernetes backup and recovery for dummies link in there. So I encourage you to check those out now and share them with your friends and colleagues. Those will be available throughout the event. Now, third, at the end of this webinar event, we will be awarding a $250 Amazon gift card to one lucky registrant. Of course, you must be in attendance during the live event to qualify for that prize. Official terms and conditions of today's prize drawing can be found in the handout section. Again, just scroll to the bottom and you'll find the link with the details there. Now, finally, one of the best benefits of this event is the opportunity to ask a question of our expert presenters. To help encourage those questions, we have a special additional prize for you. That's another Amazon gift card, this one for $50 for the best question. So after the event is over, we'll look at all the questions that came in, pick out the very best one, and contact that prize winner. Okay, with all that housekeeping out of the way, let's get into our fantastic content today. So it's my pleasure to introduce you to our speakers. We have Michael Cade, who's Field CTO for Cloud Strategy at Kasten by Veeam. And we have Sam Nichols, who is Senior Director for Cloud and Kubernetes at Veeam. So Michael and Sam, welcome.
Hey, thanks so much for that great introduction, Scott. And thank you to everyone for joining us today. Super excited to talk to you guys about cloud native data and I guess like a little bit of a statement we're making, right? Everything is stateful. But before we go, just wanted to, say a few welcome words. Michael and I like to keep these as interactive as possible. So any questions that you have, please don't hesitate to use the Q&A panel. We have got our eagle eyes on that panel open right now. So don't wait till the end. Ask the questions away and use that to steer the conversation today. And then also just a few welcome words from you, Michael.
Yeah, hey everyone, and cheers, Sam. So my focus over the last 3 and a bit years has been all about cloud native, all about Kubernetes, and even before that, it was more focused around the infrastructure world of virtualization and storage. And I know we're going to get into a lot of this stateful versus stateless, which is still an ongoing conversation that we're having, Sam, and I'm excited to share where we are as not only just a community, an industry, but equally some of those concerns and some of the things that we have to consider with that stateful approach of where that data may reside.
Yeah, absolutely. I think we're in for an interesting conversation. And like Michael, I've been focused on like the cloud and cloud native world for quite some time now. So we've been working hand in hand. And a little interesting fact for you guys as well. This is Michael's, I guess, pet name for me is the Chief Coloring In Officer, as I do technically fall within the marketing organization. So, nice little icebreaker there for you guys. Let's get started. So, let's have a look at the first misconception, which is, if we're cloud native, like we're typically dealing with stateless workloads. and the fact that Kubernetes, or I guess the myth even, that Kubernetes was designed for stateless applications. And if we actually go back to like right at version 1.0, and I believe we're coming on version 1.29 recently, or soon, Michael, but right as soon as 1.0, you can actually see that Kubernetes was designed with stateful data and stateful applications in mind. The ability to attach persistent storage to those ephemeral pods. And as time went on, a series of other innovations and features that really delivered that stateful feature set to Kubernetes. Michael, anything that you'd like to add to this slide?
Yeah, and as we've just, I think it was last week, we went over that 10-year milestone, that 10-year birthday of Kubernetes. Kubernetes version 1 was 10 years ago from last week. And let's just unearth that a little bit, in that Kubernetes is still, it's just another platform, and it's built upon compute, storage, and networking. And granted, no one can lie here. Like, Kubernetes was designed for stateless applications. Spin something up, spin something down, be very dynamic around that, and be very declarative around that. And I think, almost to that point, it was almost it's been almost a religious thing that we shouldn't run data. We shouldn't run our stateful workloads, our databases on Kubernetes. And from that day, we've had that, not argument, and some of this timeline that you see here, things like stateful sets, started that story of persistence. How could I get the database as close to my application as possible? Because I think that's the other misconception that we'll talk about, is that there is going to be a database or a data service somewhere close to that, to the front end, that maybe is a bit more declarative on in terms of deployment. And then the CSI comes along, the container storage interface, and think about that as a pluggable API that allows those enterprise storage systems and cloud-based storage systems to plug into that CSI, so that we can then start to define what that CSI needs to look like. That also means that we don't have to wait for that big Kubernetes code release 3 times a year to get our enterprise storage in-tree provisioner. CSI made it easy that we could do it out of band. It meant that we could get more storage. And now if you look at companies or storage providers using that CSI standard, that's changed the way in which we see storage inside of that compute, storage, and networking platform of Kubernetes. And then from our perspective, bringing in, not maybe 3-4 years ago, maybe even 5 years ago, the ability to bring in volume snapshots. Again, that's a native specification within the Kubernetes CSI driver, is that most enterprise storage systems and cloud-based storage will have an element of storage snapshots, or snapshots that they have as a capability. By providing that as a pluggable feature, it meant that companies like ours that protect data, we could leverage that snapshot to then take a external copy of that data and push that somewhere else. We'll get to that later on. But the other thing that I always use as a conversation starter on this misconception is when we look at virtualization, and in particular VMware vSphere, we were told not to run databases on that at the very beginning. Don't run databases inside of your virtual machines, and they had to stay on physical servers in your data center. Fast forward 5-10 years from there, is we were 100% putting our databases, our Exchange servers, on virtual machines. Kubernetes is just another platform, same as that vSphere, same as that virtualization platform, and we're seeing that same cycle happening. And it all comes down to trust, as well as some of the other areas that we're going to touch on over the next few slides.
So I'm actually going to jump around a couple of slides, because I think you bring up some really good and interesting points, Michael. So the first is just looking at a very, very high level general application architecture between stateful and stateless. And, Michael's talking about data services, typically databases, and really like the big difference between that is that data service within the Kubernetes cluster, aka a stateful application, or is it outside of that cluster? right? A stateless application. It's really just about where that data lives. Ultimately, whether the Kubernetes cluster is stateful or stateless, there is going to be state within that application somewhere, right? There's going to be persistent data within that application somewhere, likely within a database, again, whether it's inside or outside of the cluster. And as you actually look at some of the more mature adoption of Kubernetes within organizations, and this isn't even our own research, this is from Datadog, the usage of containerized workloads by category, you can actually see that the vast majority of organizations are using Kubernetes for databases. Michael, anything to add here?
Yeah, I think on the slide before, Sam, that you touched on, the stateless stateful, the one thing that I will hold my hands up here and say, okay, you got me in terms of everything's not stateful. In that, if I'm running a Hello World demo app on my Kubernetes cluster to prove something's working, and it's being exposed to a web interface, granted, that is not using a data service, 100%, and everything is within that container image. But there are very few use cases where we're just using Hello World or static web pages that are all contained within the image for that particular container. So as mentioned, I know we're going to get into this as well, but if we think about that stateful side and we're having everything inside of the cluster, think about that data service being the database, but equally you have to think about data service, and this is why I'm not saying database, is that data service could be a persistent volume claim that is storing all of your login information. How important is that login information? And the general architecture around some of those it could be a message queue. It could be the login system that I mentioned. It could be Prometheus that is storing metrics. Equally, then we have the stateless side, which might be all looking like it's stateless inside of the Kubernetes cluster, but you're going to have an element of state when it comes to an authentication. Like if you have to log into that website, that user authentication has to live somewhere, and that might be a data service outside or inside of the cluster. Equally, if it's an e-commerce site, it might have its product catalog stored in a database somewhere. It might have its login, its metrics, etc. So just to kind of paint a bit more of a picture around that and kind of put that big caveat up is that, oh yeah, you could absolutely just run stateless workloads that do not have any data at all associated to it, like Hello World. But there's and don't get me wrong, there's other IoT type services and systems that don't require any state or data service as well. But I just wanted to caveat that in there as well.
Good points. So as we start to really kind of look at more mature usage of Kubernetes, particularly in production, and again, kind of leveraging that Datadog data set that we just, I said data and data, but that Datadog data set that we just showed, right? Why might organizations consider a stateful approach to Kubernetes versus something that is stateless? So I think the first one is around latency. And again, like Michael says, this isn't something new that we're facing, right? Kubernetes is just another platform for us to run our services, our workloads, our applications on. And this is a consideration that we had in other ways of architecting applications in the past in terms of, how close do we want that data service to be to the workload to ensure that low latency, right? To get that high performance from our application, that consistent user experience. So as we look at organizations that have that intensive and extensive use of Kubernetes in production today, particularly in financial services, the public sector, telecommunications, mobile gaming, right? That data service living within the cluster, aka a stateful cluster, is something that we're seeing more and more often. Equally so around mobility as well, right? Kubernetes as an abstraction layer was designed to be highly mobile across multi-cloud, right? So being able to have Kubernetes, a Kubernetes cluster on premises and being able to mobilize that to AWS, or maybe go from AWS to Azure, or maybe bring it back on premises. If we have a data service, so something like database as a service, maybe an Amazon RDS, Azure SQL, whatever it might be, if we have that outside of the cluster, that data service then isn't benefiting from the same degree of application mobility as the Kubernetes cluster itself. But if we bring that database within the cluster, something like an EDB, that then enables that mobility. So whichever decision the business needs to make for whatever reason, maybe it's a data sovereignty, maybe it is, I don't know, we've acquired a new technology that was founded on, acquired a new organization and their technology was found on Azure, whereas we're on AWS, being able to move their stuff into AWS to take advantage of things like commits. Mobility is equally important. And again, a stateful Kubernetes cluster where a non-cloud specific platform as a service, again, like for example, a database, is going to be beneficial. Michael, anything else to add on those last two slides?
Yeah, I think both the mobility and the latency, it depends where you're starting from. If you're an existing company and you've maybe transitioned some of your application off into Kubernetes, into that maybe a stateless image, but the database still resides on a virtual machine, but now you're spanning two platforms. You're now potentially running a Kubernetes service or platform inside of your same data center on the same virtual machines, maybe next to the virtual machine that runs your database. Or you've gone into the public cloud and you've started leveraging EKS, and you're now expecting or wanting to connect back into your data center or your environment to connect to that that virtual machine. Or you're a net new environment and you're building from fresh. Then you've got to make a decision as to, okay, if you're going to use Amazon RDS or Azure SQL, then maybe you're forced to choose EKS or AKS because, well, that's going to be on the same cloud platform, and you haven't got to traverse the internet to get to that ultimately important data. Which then comes down to, okay, and the reason why it's difficult, right, to migrate your 500 terabytes of database that lives on a virtual machine, and it's now clustered with a virtual machine. It's been working beautifully for that application for years. It's very difficult to lift and shift that into a containerized environment. Or do you start new and then start putting that on? And which is why we wanted to get across that stateful versus stateful, or stateless versus stateful, isn't so much of an issue today as well. So yeah, I think the mobility of that is important. What's the best way to start our journey? Because a cloud native journey around data is going to be continuous from that perspective.
Great points. So I think some other considerations that you guys need to make around stateful versus stateless as well is around, copy data management. The ability to test our application requires that access to production fresh data. And again, if you have a data service that lives outside of the cluster, you're going to have to build those separate processes in order to connect into that production data and manage those data services for your testing capabilities. Against that, polyglot persistence as well. Michael, what
Sam,
do you
on that last point, the copy data management. So yeah. In terms of, this is about being able to leverage copies of that data and being able to put it to work to understand something about the business, the data that you have, so that you can make better business outcomes or better decisions. So for example, a customer that I spoke to last week, they're running on-prem, they're using Red Hat OpenShift, they're actually running it on top of VMware vSphere, and that's great, and that's their production environment. Their application lives on there and works amazingly well for them. But what they do is they take a copy of their production database and their application, and they clone a copy of that into a GKE cluster, and then they use Google BigQuery to glean information and get insights out of that data. that copied, cloned cluster, and it's just onto a GKE cluster. It's not onto OpenShift. And what they do is they basically get this information and then throw that in the bin. They don't need it anymore. So they're just using very small, for a very small window, they're using it to glean information out of a native cloud service, which is quite interesting. So yes, you could use it for testing applications, make sure that it's got the right access and authentication models and all of that. But equally, you could use that data set if it's in a portable format, which Kubernetes provides the ability to do so. We can go and actually glean some information from that. So copy data management has been accelerated massively as we have access to not only cloud native but equally cloud services that provide us some insight into that.
Awesome. So
yeah, if I'll touch
you
on
keep going, mate.
The polyglot persistence. So in the cloud native world, when we look at databases, traditionally in the database world, we would probably have a list of no more than 5. We can count them on one hand. As to where our databases were going to reside. They'd generally all be SQL-based databases. We would either be looking at Oracle, we would be looking at Microsoft SQL, MySQL, Postgres, and then maybe some NoSQL were coming into that. And the traditional way was, we're just going to have one database cluster, and all of our databases are going to reside on that cluster. Maybe we have one Oracle and one Microsoft SQL, but databases for all of our different applications would reside on these database clusters. In the Kubernetes or in the cloud native world, we have a much broader choice in how and where we run our databases. And we have a plethora of choice, not only between SQL and NoSQL. We equally can start to look at things like Document DB. We could start to look at other based vector databases for AI, just in there in a 2024 webinar. But we can choose the right database for the right job. We're not forced to use the same one over and over again because our licensing said so, or because we had to make that architectural decision like we did in the virtual world or even the physical world as well. So polyglot just means that we can pick and choose the right data service for the right job.
Awesome. And then the final consideration is around cost optimization. And this
the other
this
piece
is always
to consider here around cost optimization is being able to scale up, scale down accordingly what the resources are that we want to be using, and being very efficient when it comes to maybe holiday season, to be able to spin up and scale out accordingly, scale up horizontally but equally vertically according to whatever that demand was. There's two sides of this, is that one, I can be more efficient internally if I offload the management of the operating system and even the database layer and the hardware to a PaaS-based solution like an Amazon RDS that we've touched on, or a MongoDB Atlas, or any database as a service. However, that's going to cost you money because you're offloading that responsibility and that control of that. But then you've got companies like EDB, Enterprise DB, that are behind Postgres ultimately, and they've got the ability to host via an operator model, to host with a much lower TCO, total cost of ownership, on Kubernetes. And I think we're starting to see, if you look at any of your favorite cloud native databases out there, they will have either a Helm chart that will enable them to deploy their database within Kubernetes. And I would probably say in 2024 that the majority of them will have an operator that ultimately works out, deals with the lifecycle management of the database. So cost optimization, it's really about where you're optimizing yourself as a manager. Like if you want to if you're expecting to run your own RDS and have control of everything, all the bells and whistles from hardware right through to the database, then hosting your own is probably going to be the preferred. But the cost there is going to be your time, your skills, your effort, or you offload that to a managed service provider and you reap the time back that it saves you. So it's about being not optimized as in it's going to save you money, but it's going to give you the choice and the control depending on which way you choose. And that polyglot persistence also means that we can pick and choose. Like if you want to use some paths and you want to use some operator-based statefulness within your cluster, great, that also works.
Awesome. Thanks so much, Michael. And I think, again, these are all good considerations to have when it comes to maturing in the cloud, especially towards cloud native technologies like containerization, might also be functions as service, serverless, other microservices. Can you hear me okay, Michael? Michael? Can someone confirm if they can hear me?
Hey, Sam, I can hear you.
Okay, sounds good. So we're going to keep going. I'm not sure what's going on with Michael, but that might explain why there might have been a little bit talking over one another. So I apologize there. I think, ultimately, whether you're stateful or stateless, the question is that data inside or outside of the Kubernetes cluster? Again, we're seeing as organizations mature with Kubernetes, more and more persistent or stateful data is being hosted on the Kubernetes cluster itself. And that leads us on to misconception number 2, which Kubernetes applications, especially stateless ones, don't need protection. And I would say that this isn't even necessarily true of just Kubernetes, but also around just public cloud workloads in general as well. I think, as we move towards cloud technologies, whether we're going like cloud hosted, IaaS, running that application in the same way as we were on premises, there's that misperception that I'm transitioning the responsibility of protecting that data, the availability of that data to that cloud provider simply isn't true. They're absolutely going to maintain the uptime of the infrastructure itself. And as we move to things like PaaS, so like an Amazon RDS or an Azure SQL, like Michael was talking about, the actual operating system and platform itself. But the data that you put in the cloud is always your responsibility. And if you have any desire to have resilience and the ability to recover that data, particularly sensitive data like in financial services or healthcare, you've got to make sure that that data is being protected. So of course, for your stateful workloads, backup and DR is going to be essential for that stateful data, but it's not just the stateful data, it's the config maps, the secrets, the deployments, etc. within the cluster. So the ability to discover all components of that application, take a snapshot, and then get that data as a copy outside of the cluster is going to be critical. And I'm going to utilize something that happened within the last month on how important this is, and that is looking at UniSuper. So UniSuper is a superannuation fund based out of Australia. They manage about $125 billion worth of assets, and they were founded on Google Cloud. So this isn't particularly Kubernetes related. It is just a good case study on why you need a backup. Ultimately, Google uploaded some new code to this account, and it eventually deleted all data within that account. And if we're just looking at the durability, the availability of the cloud, ultimately through replication between availability zones or regions, we're gonna encounter some challenges because the deletion of that account deleted all of that organization's data across all availability zones, across all regions. And the only reason why UniSuper was able to recover is because they had taken image-based backups of their Google Cloud IaaS and sent it to another platform. That's the only reason why they were able to recover. So the ability to actually protect that data is going to be critical in ensuring your resilience. Don't 100% rely on your cloud provider or your platform provider to ensure the availability and resilience of your data. You have responsibility there as well. I think we might have Michael back from some of those issues. Michael, anything to add around, this next misconception, which is ultimately Kubernetes applications, whether they're stateful, as you see on the screen here, or stateless, there's that degree of protection that's needed. Michael, are you back with us?
Hey, Sam, this is Scott. I'm going to pull Michael out into the green room and see if we can figure out what's going on with him. So
sounds good. I should be going while we're doing this. Ultimately, as we discussed earlier on, with the exception of a few fringe circumstances, state is going to live somewhere if it's not inside the cluster. And we've got to be able to reproduce those point-in-time deployments of those applications, whether that is for disaster recovery, like in the example I just gave with UniSuper, but it might also be for compliance. Again, like what we're seeing in the industry in terms of that mature usage of Kubernetes in production, it's particularly in those public sector, healthcare, financial services industries. And we're all dealing with very, very sensitive data. And there are rigorous compliance standards around the ability to protect and recover that data. So it's absolutely something like a misconception that we first must understand, but then also plan for. The second piece is also around VMs on Kubernetes, right? Red Hat OpenShift virtualization. This is, I think, a great stepping stone for a number of organizations that are undergoing some sort of application modernization effort. They're looking at utilizing more cloud native technologies, but refactoring an entire traditional, monolithic 3-tiered application into something that is ultimately loosely coupled and has varying degrees of state inside or outside. It's a big undertaking. So the ability to run virtual machines on Kubernetes, again, Red Hat OpenShift virtualization is a great example of that. SUSE has their own version as well. There's going to be state there as well. So the ability to protect any way that we are utilizing Kubernetes today is going to be critical. I see some things going on in the side of the panel, so I'm not sure if we've got Michael back yet, but we'll certainly invite him for his take on this in a little bit. As we keep moving on, I'll start to introduce you guys to Veeam, right? And Veeam might be familiar for a number of you folks. So Veeam, almost 20 years old now, we really pioneered that native backup and recovery for virtual machines, namely vSphere and Hyper-V on premises. But in those 2 decades, we've seen a lot of change in the industry, of course, and our platform has really blossomed into being able to deliver that cyber resilience and recovery for your data, irrespective of how it's hosted or where it resides. So of course, that can be for virtual machines or virtualized data on premises, not just vSphere and Hyper-V, but a number of other hypervisors as well. It could be physical machines, right? Your Windows and Linux boxes, as well as enterprise applications that you host on-prem. But more and more, as we see about 50% of production workloads being hosted on cloud today, the ability to protect that cloud data. So that extends to AWS, whether that's like EC2 instances, RDS, EFS, Azure, same permutations there, IaaS and PaaS services, same for Google. And then, of course, our containerized workloads as well. So Kubernetes managed applications. Irrespective of how you're choosing to run that data today or that application today or tomorrow, the vision of Veeam is to again, deliver resilience for that data, for that application, irrespective of how you're choosing to host it. So we've got a number of data security capabilities to ensure the security of your backups, because we know that backups are increasingly becoming the primary target for threat actors that are seeking to bring the organization to its knees. Equally, in terms of data recovery, right? A backup is only as good as your ability to recover. So that ability to do it not just quickly and efficiently, but actually bring back something that is clean and only the data that you need to restore. And then finally, around this notion around data freedom, right? So the ability to host your applications and data in the way that best suits the needs of the business today, but also tomorrow. Backup or Veeam doesn't want to be a hurdle that gets in the way of you adopting the latest and greatest. We want to empower you, both technologically and from a licensing schema perspective, to move that data as and when you see fit. So let's double click into a couple of these and really have a look at how that pertains to Veeam Kasten, which is the ability to protect those containerized workloads part of our platform. So first up is around ransomware protection. And I think we all know how important immutability is today, right? Immutability is critical as it places that data in that write once, read many state. So once a backup for an incremental has been committed, typically to object storage, we're going to place it in that immutable state. So it cannot be tampered with, it cannot be encrypted, it cannot be deleted. And again, this is going to be critical against those threat actors who are seeking to target those backups to cripple your ability to successfully recover. So we've long had this capability for Amazon S3. We've recently relaunched Kasten 7.0, which also opened up this feature set to Azure Blob Storage as well. Also alongside that is encryption, right? Encryption is critically important, right? And that's both in flight and at rest. If we go back to things like ransomware and how ransomware first came about, again, almost 2 decades ago, it was an exfiltration attempt, right? These threat actors sought to penetrate your network, find sensitive data, download that onto a thumb drive locally on their machine, and then extort you and say, they will share said data, company secrets, PPI, PHI, whatever it might be, PII or PHI, if you do not pay this ransom. That did evolve into, corrupting the data, encrypting it themselves. But given that we've got immutability and a number of degrees of measures to protect our backup, that exfiltration, it's come full circle, right? History has a tendency to repeat itself. Exfiltration attempts are on the rise. Encryption is going to be critical. So even if they do get their hands on the data, they cannot read it. Same can be said for things like Kubernetes native RBAC, so that ability to deliver secure self-service backup and restore capabilities across teams and personas. So maybe to the application owner that is developing and building on Kubernetes, instead of them launching a ticket and to have to recover data, they can do that themselves. And then with a number of other adjacent vendors within the security ecosystem, right? So SIM tools, policy as code, key management services, SIM tools. We've recently in 7.0 also released integration with Azure Sentinel. So that ability to ingest that SIM data into Veeam Kasten.
Sam, hopefully I'm
You're
back
now, Michael.
Cool. Just turn it off and on again and it'll come.
I think
just on the last one, the security side of things, mate. So spot on, much more than just a color inner. But you're exactly right around immutability obviously being very important, and also encrypting those. The one thing I will say about that security ecosystem that we've seen in the cloud native world is the approach to being cloud native. So we've seen a lot more new security vendors that only play in the cloud native world. So the likes of Kyverno being a policy as code type engine, same as Open Policy Agent, being able to integrate into those so that you're setting guardrails of your Kubernetes cluster, so that if a developer or an SRE is deploying an application that has some sort of persistent storage inside of the cluster, then they're forced, the guardrail is, well, you have to have a backup of that. So integrating into cloud native services where it makes sense. Equally around KMS, the likes of HashiCorp Vault, making sure that there's the external secrets management engine that is going to look after and rotate keys so that you're not having to look after that manually. So we're shifting left when it comes to automating some of this security to some of the best of breed options out there in the cloud native ecosystem.
Awesome. Thanks for that, Michael. I'm glad you're back. So let's go on to really what the foundation is, which is around the ability to recover, right? Michael, talk us through like what a recovery might look like if we didn't have something that was, let's just say, as simple as Kasten.
So the best way to describe this is that, and most of my common talk track is I've got everything in GitHub, so I don't need to protect all of my Kubernetes objects. And then I say, what, do you store your database in version control systems? And generally speaking, nobody does. You're talking terabytes, petabytes of data, and your version control system doesn't do that. Yes, it will protect, or at least it will give you a place to store your deployments, your YAML manifest that build up your Kubernetes objects, but it could also contain the code to manipulate that data. One of the sessions that I do is around integrating backup into your GitOps pipeline or into your CD pipeline, and it highlights the fact that I could easily I could make a mistake, or someone malicious could make a mistake by putting a way in which they can manipulate your data, and that will affect the database that is deployed within your application. How do you then get out of jail from that perspective without a way of being able to protect that off, either using volume snapshots or offloading that into S3? And the answer is you're either going to be using scripts, which if you've gone down that polyglot persistent type manner, you might have 10 plus different data services that you now have to write a script, maintain the script, and look after all of those different varying backups. Whereas from a Veeam Kasten perspective is that we're concentrating on orchestrating that whole job of scripts and complexity, because you've got more important things to worry about, like getting other workloads into this platform and taking advantage of Kubernetes. So we're removing that. The other aspect is that the scripts are generally going to be designed around application consistency, but it might be using something natively like PG dump, Postgres's native way of being able to dump something out to a tar file. We're going to be looking at the whole application consistency. So where we mentioned around all of the Kubernetes objects and all of the different data services that make up that application, we're going to capture that at the same time. We're going to instruct the whole application at that point. Even if it's out using Amazon RDS, we're going to reach out of the cluster and get a copy of that data and then export that to whatever that target location needs to be. The other aspect, the middle one there, is around intelligent policies. And that's really about, one, being dynamic to discover your applications, and secondly, being able to define or understand what that application is before you've even created that backup job. So we know if you'd know if there was a characteristic that looked like Postgres, so that we would then assign a Postgres flag on that. We call it a blueprint, and that would enable us to perform the correct tasks against that as and when we needed to.
Awesome. And then the final around, just a double click into what our pillars are and what we're ultimately trying to empower organizations with is that ability to gain that application freedom, right? Again, they're your applications, run them where you want, but how you want as well. Whether, again, that is, a 3-tiered app as VMs on-prem, whether it's the same mantra but in the cloud, or starting to decouple those applications and running them more cloud native, right? More maturely. Again, it's around that application mobility across all of those different infrastructures, on-prem, AWS, Azure, Google Cloud, the list goes on, but also all the different types of distributions out there. And we've got a little bit of a slide on, how Veeam Kasten has the broadest ecosystem of supported distributions, infrastructure, and applications within this ecosystem. And then finally, as I was mentioning earlier on as well, it might not just be like our traditional containerized workload. It might be running virtual machines on Kubernetes as well. Veeam is ultimately here to help support how you want to run that workload today, and also enable you to run it how you might want to do so tomorrow without skipping a beat when it comes to making sure that application is resilient as possible. We do have a question that's come in from Marek. What type of cost savings are reported? It's really a broad spectrum, Marek. Veeam services over 500,000 organizations now across the world. And you don't do that without supporting, right down to the small, medium business, all the way up to the enterprise. So those cost savings can be in the tens of thousands, all the way up to multiple millions of dollars. I would encourage you to head over to veeam.com. Under resources, we've got customer stories, and you can see organizations that might be within the space that you're in, and kind of how they're using Veeam today, and what kind of operational efficiencies and cost savings that they are witnessing. Ultimately, I think it comes down to three big buckets, right? The first one is around those operational savings, right? Instead of having something that is open source or custom built in-house and having to manage people there, right? The software might be free, but the people aren't. There are certainly operational savings there. The next is around infrastructure savings, right? What we can do when it comes to, leveraging different types of storage, particularly in the cloud, that can offer, much, much more cost-effective long-term retention, right the way down to like fractions of a cent per gigabyte per month. You're ultimately going to see infrastructure savings there. And then the final one is around like the speed of recovery. Michael just walked through like what it might look like to recover using, custom in-house scripts or open source software versus something that's Kubernetes native and purpose built for Kubernetes. If you can reduce that downtime, there's ultimately going to be some degree of cost savings there as well. If it might take you hours or days versus weeks, sometimes months to recover, there's absolutely going to be some cost savings there. Michael, anything that you want to add around that?
Yeah, I think there's a couple of so around cost savings. I think it's all going to be dependent on your application, your data set, where you're looking, where your skills are. I think we often think about cost optimization as how much dollar can we save, when actually it could be a much simpler or more complex when it comes to like the personnel and the skills that we have within house. That might force us to make a costly decision, but it might be the best for the business, but equally it might be detrimental to the business if we have to offload some of that effort to PaaS-based services. So I think it also depends on the business and the application and the data that you're looking after.
I'm going to do a shameless plug here as well, Marek. We are actually working on a calculator to help organizations visualize this from all the different aspects that Michael and I just spoke about. I would anticipate that will be ready come the end of the month. So I'll take a mental note in order to actually directly send that to you. And you can kind of put all of your different statistics in there in terms of like your size of your organization. It looks at revenue of your organization. How many Kubernetes clusters do you have? How many people do you have? It's no more than, I think it's 12 questions. And then it kind of spits out that answer for you to kind of give you an idea. So we're kind of coming up a little bit on time. So I'm going to push that slide here around the different distributions that we protect. It's a big logo slide, but across all the different data services like RDS, Cassandra, MongoDB, all the different flavors there, all the different flavors of distributions, whether that's EKS Anywhere, Azure Kubernetes Service, Google Kubernetes Engine, DigitalOcean, the list goes on. Same from a storage infrastructure perspective, and then those security services and the integrations that Michael was talking about a little bit earlier as well. The ecosystem that we integrate with and support is truly vast, and much more than any other kind of like legacy or traditional backup. So again, having that Kubernetes native data protection service that gives you that application freedom, that application mobility is really kind of where Veeam shines. Michael, anything to add here?
Yeah, I think this slide gives us the ability to talk about the freedom of choice. We already know that there are so many different, and this isn't exhaustive by any stretch, with the Kubernetes distributions mentioned. Also, data services, there's 100 more cloud native or different databases that we can see and use within within the ecosystem. Same for storage, same for security services. You can bolt on like Microsoft Sentinel on there. You can add other services. It will depend on where you are, what you're using, what you've inherited, etc. I think from a data protection point of view, and this spans the whole Veeam data platform, including the Veeam Kasten side, is the ability to hook into whatever you're using to be able to give you that peace of mind that you've got that backup, you've got that recovery, you've got that granularity and that freedom of, okay, we're on this today, but tomorrow maybe we're going to be on something different. And this, even though you might never go to something different, the peace of mind is sometimes just knowing that you're not locked out of that movement rather than being locked into this particular place that you're in today.
Absolutely. So as I mentioned, we support more than, 500,000 organizations across the globe. And, in line with Marek's question, if you're looking at how organizations are using Veeam today, specifically as it pertains to Kubernetes, you can head over to veeam.com. I believe there's also a number of customer success stories in the little packet that we'll send you after this. They'll give you a great idea as to kind of the benefits that they're seeing from using Veeam Kasten. But if you're one of those folks that likes to get hands-on, you can get started with Veeam Kasten today. We offer a fully featured free trial for up to 5 nodes, and there's no time limitation on that as well. So again, that's in the handout that we'll send, but if you feel like scanning the QR code that is up on screen, please feel free to do so. And with that, we'll just open it up to any more Q&A or parting comments from Michael.
Yeah. Okay. Great. So this is Scott. So we've got a couple of questions that have come in. One here, they're asking, what would be the benefits of consolidating stateless and state workloads on Kubernetes?
So I can take that one. Is one of the benefits is that your team that in consolidation of bringing everything into one platform, you would have to look after multiple platforms. By bringing everything into that Kubernetes platform, it means that I only have to look after that one platform. So that the benefit of that is maybe the cost reduction, the skill reduction that you need to have. But equally, all of that other points around things like latency, it means that the data is right next to the production workload, etc. So there's a lot of benefits from it, but I would say the biggest benefit would be the reducing the amount of footprint that you have within different platforms.
Okay. All right. Excellent. Another question here. Can you run VMs on Kubernetes? And if so, how should they be protected?
Yeah, very good one, actually. That was a part of the data freedom slide that Sam shared. One thing that we are seeing massively over the last couple of months due to certain things happening in the virtualization space is people looking to move their workloads to, again, that consolidation that I just mentioned. How can I run VMs alongside containers? Kubernetes was the de facto container orchestration engine. Can I run VMs there? And there's a project called KubeVirt that enables us to run virtual machines on our Kubernetes clusters. From a Kasten perspective, we today support the protection of virtual machines running on OpenShift virtualization, which is the Red Hat's version of KubeVirt. They use KubeVirt under the hood, but they put some bells and whistles on top of that. And then we're also in the process of validating our protection with SUSE's Harvester platform as well. So we are seeing it. That's not to say like we will be able to protect other KubeVirt variants, but from today we're focused on those two vendor supplied or supported variants more than anywhere else. So, but I think that's a very interesting thing, right? When we look at virtual machines on Kubernetes, ultimately that is the definition of stateful. You wouldn't want your virtual machine to be ephemeral, like we mentioned before. We would very much want our application server running on a VM to come up the same every single time. And actually, what I think we'll see is for those databases that are large and we can't really break them down and start to containerize parts of that application that uses it, I think what we're going to see is that there's an easy latency win by just being able to lift our virtual machine up out of a virtual machine hypervisor and drop them into OpenShift virtualization, for example. And then we protect that in a similar way to what we protect virtual machines anywhere else.
Oh, fascinating. Okay, excellent. So this next question may have come in before the sort of logo eye chart there, but I don't recall seeing GitOps listed. So the question was, can Kasten integrate into any GitOps implementation?
Another good question. I mentioned this actually a little bit. That I've done a session around integrating backup into your GitOps pipeline. And GitOps or CD pipeline, just a way in which, or GitOps is a way in which we're going to use version control systems such as GitHub, GitLab, etc., as our source of truth. Well, it should be the source of truth anyway. But actually, what we're going to do is when we update the code, I want our application to automatically be updated out in the production and staging environments as well. So this is where I was saying that maybe going from version 1 to version 2, there might be a way in which you manipulate the database using config maps or even just SQL scripts to be able to address something within that data set. Anything that manipulates that data or that application for that matter, you want to make sure that you're taking a dynamic copy of that database so that you could roll back to pre whatever version that messed up. So if you're going from version 1 to version 2, everything might have been all good. But if you're then going from version 2 to version 3 and something manipulates a change in that database, then you may want to roll that back. So having a backup as part of that process, a part of that GitOps pipeline, would give you the ability to roll back. It also gets away from the more scheduled backup jobs that we're probably used to in more virtualization environments where, I need to run my backups at 8 p.m. every night and I need them to be finished by 7 a.m. because the workforce are coming back in. This really is a policy-driven approach where I need to back up when something is about to change, before something is about to change, so that I've got a rollback for that if and when something bad happens.
Okay, excellent. And last thing, Michael, same kind of tease that
Hopefully
maybe you'd have
helps.
a closing thought. Anything else that you want to add before we close here? All right. I think we might be having some trouble there. Anyway, I would just want to thank Sam and Michael for just putting together a really informative presentation here and for all their insights in the Q&A. This has just been a fantastic session. And before we close, it is time for the Amazon gift card prize drawing. And the winner of that $250 Amazon gift card today is Jeff Luxemburger from California. So congratulations to Jeff. We'll be in touch to get you your card. And just a quick reminder that you do have, those 5 handouts available, including the link to give Kasten a run. That was similar to the QR code there. It's the free Veeam Kasten link there in your handout section. So last chance to click on that one. And with that, on behalf of the Actual Tech team, I want to thank Veeam for making this event possible. And thanks as always for attending and for your great questions. That's going to conclude today's event. Have a fantastic rest of your day.